Hello everyone, I'm Jed Shlackman. I work as a mental health counselor as well as a hypnotherapist and energy healer. So I work in both the mental health field and the holistic health field. In this video I'll be speaking about a controversial topic, and this is the subject of fluoridation, adding fluoride to the water supply, also the use of fluoride in dental products. So we're going to look at some of the science, the biology, and how fluoride functions in terms of dental health, mental health, and general overall health. So what is fluoride? Well, fluoride compounds are compounds that have the element fluorine in them. Fluorine is one of the halogen elements in the same family of elements, you could say, as iodine and chlorine and bromine. So in terms of the human body's functioning, we know that iodine is a significant element. It's used in synthesis of thyroid hormones. Chlorine, that's also significant. You have chlorides, different salts that have the chlorine element in them. But fluorine and fluoride is something that's not normally considered as needed or essential for our health. Going back many decades into the early part of the 20th century, there was research done which seemed to show that there was some benefit for increasing exposure to fluorine or fluoride in terms of dental health and preventing the development of cavities. So the idea that fluoride in the compounds that are present in water could somehow improve mineralization of the teeth and prevent the development of dental cavities. That research was kind of latched onto by certain industrial interests around that time. Back at that time, you had the aluminum processing industry. They had fluoride compounds as a byproduct of the manufacturing of aluminum. So this fluoride waste was something they needed to dispose of. And to dispose of that, they found out they could promote it as something that was beneficial for teeth, for dental health. And the Dental Association got attached to that. They were promoting use of fluoride in dentistry and adding it to the public water supply. So it became a very common and widespread practice in America and some other countries. However, over the decades, a lot of research has accumulated showing that there are detrimental, harmful effects of exposure to elevated levels of fluoride. So there's been this ongoing controversy. On one side, you have people saying that it's beneficial and essential for dental health, for protecting teeth from cavities. And then on the other side of this debate or controversy, you have people focusing on the evidence that fluoride is actually contributing to a range of harm to our health, including neurological and mental health, endocrine health, bone health. So a widespread set of potential problems there from being exposed to fluoride, even at the levels or doses that are typical with addition of fluoride to public water. So we're going to explore some of the evidence related to that controversy, and I'm attempting to provide a hypothesis, in a sense a theory that kind of puts the pieces together and explains what both sides are claiming, how that all fits together, and what the ultimate conclusion about all that is, whether it's truly beneficial to have elevated levels of fluoride in the water, to be exposed to that beyond a very natural minimal amount of exposure. And I hope that this discussion gives you some more insight into this topic. This is not intended as any form of medical advice or medical diagnosis. This is just some educational information, some exploration of empirical research. You're obviously free to draw your own conclusions, to make your own decisions about what you'd like to do for your own personal health, including dental health. So that's the disclaimer I present at the beginning here. So now we're going to look at some of the significant science of fluoride, how it's functioning in the body and how the body's reacting to the presence of fluoride. And to start out with, I'll be bringing up a few studies that you can find in the PubMed database online. So this is not something that's hard to find or obscure. Anyone can look up these pieces of research. And the first one here is about fluoride exposure and duration and quality of sleep in a Canadian population-based sample. So this is a study that was done in Canada. The study authors are Jasmine Cunningham, Hugh McCaig, Ashley Mallon, David Flora, and Christine Till, published in 2021, the Journal of Environmental Health. And the abstract of the study says fluoride from dietary and environmental sources may concentrate in calcium-containing regions of the body, such as the pineal gland. The pineal gland synthesizes melatonin, a hormone that regulates the sleep-wake cycle. We examined associations between fluoride exposure and sleep outcomes among older adolescents and adults in Canada. We used population-based data from cycle 3, years 2012 to 2013, of the Canadian Health Measures Survey. Participants were aged 16 to 79 years, and 32% lived in communities supplied with fluoridated municipal water. Urinary fluoride concentrations were measured in spot samples and adjusted for specific gravity, and water fluoride concentrations were measured in tap water samples among those who reported drinking tap water. We used multinomial and ordered logistic regression analyses using both unweighted and survey-weighted data to examine associations of fluoride exposure with self-reported sleep outcomes, including sleep duration, frequency of sleep problems, and daytime sleepiness. Covariates included age, sex, ethnicity, body mass index, chronic health conditions and household income. And they then report the results. The median, MEDIAN, UF, so that's urinary fluoride concentration, was 0.67 milligrams per liter. Median water fluoride concentration was 0.58 milligrams per liter among participants living in communities supplied with fluoridated municipal water, and 0.1 milligrams per liter among those living in non-fluoridated communities. A 0.5 milligram per liter higher water fluoride level was associated with 34% higher relative risk of reporting sleeping less than the recommended duration for age. The relative risk was higher, though less precise, using survey-weighted data. Urinary fluoride was not significantly associated with sleep duration. Water fluoride and urinary fluoride concentration were not significantly associated with frequency of sleep problems or daytime sleepiness. Conclusions: fluoride exposure may contribute to sleeping less than the recommended duration among older adolescents and adults in Canada. So in that study, they were finding some indication that it was having an impact upon sleep. So the pineal gland is where melatonin is produced naturally in the body, which regulates the sleep-wake cycle, as I mentioned. And it's known that over time, the pineal gland tends to calcify as you get older, and part of the effect of that is reduced melatonin and reduced amount of sleep. So generally, older people have less hours of sleep at night than younger people. So insomnia is certainly a concern, and if fluoride is in some way contributing to that, you'd have to consider that as a risk of fluoride consumption. So that's something we're going to keep in mind as we look at some more studies, some more evidence of what's happening with fluoride. We also know that there have been a number of studies from around the world showing that fluoride in water, or elevated fluoride exposure, correlates with lowered IQ in children. So that's showing another sign of some type of brain or neurological effect affecting the mental health, cognitive functioning. So next we're going to look at a study that talks more specifically about the pineal gland and pineal calcification. This one is pineal calcification, melatonin production, aging, associated health consequences, and rejuvenation of the pineal gland. This is from the journal Molecules in 2018, and this includes Chinese authors. I'm not so great at the pronunciation, but there's Dun Shantan, Bing Chu, Chinjia Zhao, and Russell Ryder. Those are the study authors. And at the start, they say the pineal gland is a unique organ that synthesizes melatonin as the signaling molecule of natural photoperiodic environment and as a potent neuronal protective antioxidant. An intact and functional pineal gland is necessary for preserving optimal human health. Unfortunately, this gland has the highest calcification rate among all organs and tissues of the human body. Pineal calcification jeopardizes melatonin's synthetic capacity and is associated with a variety of neuronal diseases. In the current review, we summarize the potential mechanisms of how this process may occur under pathological conditions or during aging. We hypothesize that pineal calcification is an active process and resembles in some respects of bone formation. The mesenchymal stem cells and melatonin participate in this process. Finally, we suggest that preservation of pineal health can be achieved by retarding its premature calcification or even rejuvenating the calcified pineal gland. I'm going to read a few different other excerpts from parts of this article. It says it was reported that several physiological or pathological conditions indeed alter the morphology of the pineal glands. For example, the pineal gland of obese individuals is usually significantly smaller than that in a lean subject. The pineal volume is also significantly reduced in patients with primary insomnia compared to healthy controls. These observations indicate that the phenotype of the pineal gland may be changeable by health status or by environmental factors, even in humans. So we're going to skip ahead to a significant part of this study. It goes into a lot of detail about the pineal gland, its structure, about melatonin, and how that is synthesized. Melatonin is a very significant hormone. In addition to promoting sleep, it's an antioxidant that protects our body from reactive oxygen species or free radicals, and it therefore helps protect the brain from being harmed by those free radicals. So our overall health is supported by melatonin. It's actually a cancer preventive molecule. So I want to get to the part of the study that does bring up fluoride and how that might relate to the calcification. So let's come toward the end of the study. So I will go through the conclusions of the study here. Accumulating evidence indicates that pineal health is important to preserve the optimal physiological status of animals, including humans. Pineal gland is a unique organ which synthesizes melatonin as a signaling molecule of natural environmental changes and is a potent neuronal protective antioxidant. I mentioned that earlier. We hypothesized that pineal gland calcification is an active process which is similar to bone formation. High levels of melatonin generated by the pineal gland promote pineal gland calcification, since this molecule enhances the differentiation of MCSCs, and I'd have to go back to see what that abbreviation stands for, into osteoblasts and osteocytes, so those are bone cells, to compensate for the functional loss of the pineal gland. Pineal grafts have been performed in different organs and tissues. The grafted pineal, however, cannot mimic the functions of the in situ pineal gland, especially since they do not establish the normal melatonin circadian rhythms. Thus, perhaps the best way to preserve a healthy pineal gland is to rejuvenate the in situ pineal gland by decalcification and then stem cell injection into the gland. It is speculated that a healthy pineal gland would be responsive to high levels of melatonin production, which benefits to immunomodulation, metabolic balance, and anti-cancer effect generally. We speculated that a more suitable way to preserve a healthy and functional pineal gland is either to retard its calcification or to recover the functions of the calcified gland. As mentioned, several pathological conditions might promote the premature pineal calcification. However, the environmental biohazards may also contribute to its development. One of them is fluoride. It was reported that the pineal gland in goosander concentrates fluoride, which is a water pollutant. The level of fluoride in the pineal gland of goosander was 5-fold higher than that it is in the brain of the animal. The similar results were observed in the aged human pineal gland. In addition, the high level of fluoride in the human pineal gland is positively related to its calcium accumulation of the gland. Thus, decrease in environmental fluoride pollution may be helpful in delaying or avoiding premature pineal calcification. So that's a part of the study, the article in that study that refers to fluoride and its role in calcifying the pineal gland. So this is something to consider when you think about mental health, because sleep and melatonin, that's something very widely discussed in terms of its impact on our mental functioning. And if fluoride is interfering with that, fluoride would certainly have a negative downstream effect on mental health. Now, in dentistry, they use the idea that when you expose the teeth to fluoride, it fosters calcification. So they want to get the teeth more calcified because building the minerals there in the teeth reverses or prevents tooth decay, the breakdown of the tooth. Now, our teeth are constantly being eroded and rebuilt. It's this ongoing process. Even bones in our body are continuing to remodel, to break down and reform over time. And with our teeth, what happens is that they get exposed to corrosive acidic materials, acids from your food, acids from the bacteria that feed on whatever residue gets left in your teeth after you're eating. So there's this gradual breakdown that can occur if you're not remineralizing as quickly as the teeth are being eroded. So you need to keep that balance where you're getting enough remineralization to compensate for the demineralization. So dentists believe that by using fluoride, you're somehow boosting or accelerating that mineralization process of the calcium mineral compounds being deposited back into the teeth. However, if we look at research about what fluoride is doing systemically to your bones and your skeleton, and your teeth are part of that skeletal structure, we find there's some significant problems where it's not actually forming healthy bone tissue, it's forming, in a sense, an abnormal composition of that bone matrix, which can lead to problems in the long term. It could lead to more brittle bones, other problems that we'd want to avoid. So we'll look at some relevant research that addresses the topic of bones, how fluoride impacts our bones and skeletal structure. So the study I'm going to reference now is one titled, titled Bone Quality in Fluoride-Exposed Populations, a Novel Application of the Ultrasonic Method. And this is in a publication called Bone Reports. The authors are Tewodros Godebo, Mark Joland, Reda Teklahamanot, Arti Shankar, Biniam Alemayehu, Getachew Asefa, Gary Whitford, and Amy Wolf. So you have a multi-ethnic group of researchers there. And it says, for the highlights of this study, a novel ultrasonic bone quality biomarker was tested in a population with low to high exposure to fluoride. Negative associations were found between fluoride exposure and bone quality. Decreased bone quality reflects net bone loss, abnormal mineralization, and altered collagen. The finding highlights that fluoride exposure has complex effects on bone quality that go beyond changes in bone density alone. Various studies, mostly with animals, have provided evidence of adverse impacts of fluoride on bone density, collagen, and microstructure, yet its effects on overall bone quality, strength, has not been clearly or extensively characterized in human populations. In this observational study, we assessed variation in an integrated measures of bone quality in a population exposed to wide-ranging fluoride levels from 0.3 to 15.5 milligrams per liter. Actually, I'm not sure if that's milligrams or micrograms. It's mg per liter in drinking water using a novel application of non-ionizing ultrasonic method. And coming to the results and conclusions, They report, we found negative associations between fluoride exposure and bone quality at all 3 bones. Adult tibial SOS showed the strongest inverse association with fluoride exposure, which accounted for 20% of the variance in SOS measures. In adjusted analysis, a 1 mg per liter increase in fluoride in drinking water was related to a reduction of 15.8 ms, whereas a 1 mg per liter increase in 24-hour urinary fluoride was linked to a reduction of 8.4 ms of adult tibial SOS. Among adolescents, in contrast, weaker and non-significant inverse associations between fluoride exposure and SOS were found, while age, gender, and body mass index were more significant predictors than in adults. These results are, here's a conclusion, these results are indicative of a fluoride-induced deterioration of bone quality in humans, likely reflecting a combination of factors related to SOS: net bone loss, abnormal mineralization, and collagen formation, or altered microarchitecture. The portable and low-cost ultrasound technique appears potentially useful for assessment of bone quality and should be tested in other locations and for other bone-related disorders to assess the feasibility of its more extensive diagnostic use in hard-to-reach rural regions. So we're placing this research into this puzzle of what is fluoride actually doing in the body. We're looking there at the effect on bone formation. So it's creating a negative impact on the quality of bone. And of course, teeth are bone, so you could say that it might be a catalyst for formation of tooth material. So by exposing the teeth to fluoride, it's triggering some sort of a process of depositing minerals there, but it's an abnormal mineral structure that's forming in reaction to the fluoride. And in my point of view, just looking at overall biology and what fluoride is, it's a compound that's toxic in very low doses. So our body is responding to this fluoride as a toxic threat, and it needs to do something to protect itself from this toxic hazard. And what it's doing is it's forming bone or calcification around the fluoride to, in a way, sequester it. It's trapping the fluoride there in the bone so the fluoride won't migrate further into your body, so it won't get into your nerves, into your brain, into your pineal gland, etc. So it's kind of the first line of defense is to calcify, to trap that fluoride in that spot so it won't seep in any further. So your teeth are there in a way protecting you by calcifying to hold that fluoride. So by doing that, yes, perhaps it might to some extent reduce the likelihood of cavities appearing there. So unhealthy bone is better than no bone at all from the cavity perspective. But in the long run, it's not forming healthy dental material, just as it's not creating healthy bone mass or bone matrix in your body. Plus, if it does filter even further into your body, that fluoride can create other health problems that are even more serious. It could create neurological problems. It could lead to Alzheimer's and dementia and things of that nature. So your body will create unhealthy bone material first before allowing that fluoride to get into the nervous system and into the brain. So if you're concerned about maintaining bone material and maintaining tooth material, you would look into other ways of supporting mineralization, not by kind of tricking your body by, in a sense, giving it a toxin to react to calcify. You can actually create healthy bone and healthy teeth with the minerals that your body truly needs, that are actually nourishing your body and helping it maintain its healthy process of bone mineralization. So that means getting magnesium, calcium, phosphorus, getting vitamin D and vitamin K. So all the elements that your body are using for its normal process of bone and tooth remineralization. So having a healthy diet, not exposing your teeth or your body in general to over-acidity. We know that a diet that's kind of highly acidic, that actually causes your body to lose minerals, because the acid waste needs to be buffered by the alkaline minerals, so your body will start to get depleted of calcium and magnesium and other minerals that it's using to protect itself. So those are some of the reasons why people end up with things like osteoporosis. It's that the minerals are being depleted from their body, and if you're using something like fluoride, your body might put some of the minerals there calcifying around the fluoride to hold it there, to keep it from migrating into more sensitive regions of your body. But in the long run, you're not allowing your body to use those alkaline minerals in the more balanced way that it would usually be directing the deposition or depositing of the minerals. So to kind of summarize and review, there's evidence of neurological problems related to fluoride, bone quality problems related to fluoride, sleep issues related to fluoride. We also have the concern in terms of fluoride exposure that you have endocrine hormones, you have thyroid hormones that depend on iodine, and iodine in the body kind of competes with fluoride and chlorine and bromine, the other halogen compounds. So those other halogens can interfere with with iodine metabolism. So the fluoride that you're exposed to could affect your body's iodine metabolism and thyroid hormones. So endocrine issues are another concern related to fluoride and overexposure to fluoride, especially if you're underexposed to iodine. So if you have limited absorption or ingestion of the iodine element and you have some higher level of fluoride exposure, then the fluoride is going to go into your body where the receptors are, where iodine would usually be active, and therefore you're not able to utilize iodine properly, which leads to those downstream endocrine effects. We have an increasing percentage of the population who are suffering from thyroid disorders. So if you can prevent tooth decay in other ways with healthy diet and basic dental hygiene, you don't want to try to use fluoride as a replacement for that, since fluoride has all these other potential harms associated with it. So we can think of fluoride as something that for many years appeared to the dental profession as a way to protect teeth from cavities because it triggers calcification. Calcification is part of the process of teeth formation. However, they didn't realize that the way it did that is producing an unhealthy form of calcification. It's the body perhaps trying to calcify to protect itself from a hazard or irritant, which is represented by fluoride. And so you might initially see less cavities, but there are better ways to prevent cavities, and in the long term, more and more health problems can start to arise as a result of that accumulation of fluoride and calcification happening in other parts of the body around the fluoride. For those that are interested in the topic of fluoridation, I would encourage you to check out the Fluoride Action Network. They have a website called fluoridealert.org, FLUORIDEALERT.org, and they've been involved in legal actions that have challenged the use of fluoride in the water supply. They've been very instrumental in that public health campaign to actually get our public health institutions to look at the real evidence, the real science, and to take action to change the policies that have been in place in many areas. For those that are interested in holistic health in general, I invite you to visit my website, phinsights.com. That's PHINSIGHTS.com. For now, I'd like to wish everyone a wonderful day. Namaste.